The objectives in this topic are plot points in the rectangular coordinate system, graph equations in the rectangular coordinate system, interpret information about a graphing utility's viewing rectangular table, use a graph to determine intercepts, interpret information given by graphs. This is a Cartesian plane, also known as a coordinate plane or an XY plane, or a rectangular coordinate system. Have you ever played Battleship? When you're playing Battleship, you would call, for instance, D4. And D4 would mean you go and find the D on one end and the 4 on the other end. And where the 4 and the D meet, that's where you would strike D4. A Cartesian plane, a rectangular coordinate system, works the same way. This horizontal axis is the x-axis. This vertical axis is the y-axis. The x-axis is just your standard number line. 0 in the middle, positive numbers to the right, negative numbers to the left. The y-axis is a number line straight up and down. 0 in the middle, positive numbers up, negative numbers down. I'm going to go ahead and clear these numbers out of here just to declutter a bit. And I'll indicate positive, negative again. So positive numbers to the right, negative numbers to the left, positive numbers up, negative numbers down. This is separated into 4 quadrants. We start numbering our quadrants in the top right, and we move counterclockwise. So that's against the direction of a clock. Clock goes this way. That's clockwise. We go counterclockwise when we're numbering. 1, 2, 3, 4. Okay. And we use Roman numerals. 1, 2, 3, 4. Quadrant 3 is lower left. Quadrant 1 is upper right. Quadrant 2 is upper left. Quadrant 4 is lower right. A point, say this one here, 1, 2, 3 to the right, and 1 up, would have both an x coordinate based off of its position on the x-axis and a y coordinate based off of its position on the y-axis. And these coordinates are going to be of the form x comma y, where x and y are in parentheses. So in parentheses, there are two coordinates. The first is an x, the second is a y. And this one here, the x, 1, 2, 3, positive 3, the y, 1, positive 1. So this point would be the point 3, 1. Notice it's a positive number and a positive number because it's in quadrant 1. And anything up here in quadrant 1 is going to have a positive x because it's to the right, and it's going to have a positive y because it is up. So all points in quadrant 1 will be positive, positive. All points in quadrant 2 then are going to be negative positive because the x is negative. It's going to be to the left, but the y is positive. It's going to be up. 3. Quadrant 3, the x will be negative because it's to the left. The y will be negative because it's down. Quadrant 4, the x will be positive because it's to the right. The y will be negative because it is down. When we draw ourselves a coordinate plane, you don't have to put in quadrants 1, 2, 3, and 4. You don't have to put plus, minus. All you have to do is make the coordinate plane, label your x-axis, and label your y-axis. That's all you need, an x and a y. So let's find the point -3, 5. Well, our first coordinate is the x, our second coordinate is the y. The x should be -3, and the y should be 5. Now, I'm not going to put a mark here and a mark there, but I am going to kind of tell you to imagine where these intersect, just like Battleship, an x of -3 and a y of +5. Just like Battleship, where they meet is where our point will be. And let's say it's point B. We can call that B. Zeros are where things might get a little cloudy for you. So let's learn a little bit about our zeros here. First of all, we got the double zero, and it's going to be right here because it's a 0 on the x and it is also a 0 on the y. This actually has a special name. That special name is the origin. Let's say we had this point right here. In fact, let me change the position of that. That's under the light spot. Let me go with this one down here. The x is still going to be 0 because it's not going left or right any on the x-axis, but it did go down. It went down 1, 2, 3, 4, 5. So this point would be 0, -5. We'll talk about that in a second, but I also want to talk about this point right here. Now the x is 1, 2, 3, 4, but the y has not moved any from 0. So the y is 0. What I want to point out here is that something that's directly on the x-axis, the horizontal axis, has a y of 0. Something that is directly on the y-axis has an x of 0. These types of points that happen to fall right on the axes are called intercepts because they intercept the axis. An x-intercept intercepts the x-axis. It has a number for x, but a y of 0. So an x-intercept has a y of 0. A y-intercept intercepts the y-axis. It is on the y. It has a number for y, but an x of 0. Let's say we had the equation y equals x plus 2. A solution x, y would be an ordered pair. And by the way, that's what we call these, ordered pairs, because order matters. It's a pair of numbers where the order matters. The first is always x, the second is always y. If you switch them around, it wouldn't be the same thing because the first is always x and the second is always y. So a solution, xy, would be an ordered pair that makes the equation a true statement. Now, maybe you're suffering from whiplash right now. You might be going, hold on, you were just talking about a graph. You were putting points on there. Now we're talking about an equation. Tell me, what's happening? Well, what's happening is I'm showing you that an ordered pair, those things that we're putting on the graph as points, would express a solution to an equation if it's true. So let's test out a few possible ordered pairs and see if they are solutions to this equation. Let's test 0, 2. Let's test -4, -2. Let's test 2, 4. Remember, when we see an ordered pair, what we are seeing is X and Y. So let's test this one. X is 0, Y is 2. That one's true. So that is a solution. Let's test the second one. X is -4, Y is -2. So -2 equals -4 plus 2. -4 plus 2 is -2. Boom, that one checks too. So that one's a solution. Let's check this one, 2, 4. X is 2, Y is 4. That checks out. So all three of those are solutions. Does that mean everything's a solution? No. It means that these three are. But guess what? I picked these three because I knew they were. Let's try 1, 8. X is 1, Y is 8. That one doesn't check. That one's not a solution. It's only a solution if it satisfies the equation. If when we plug in X and Y, we get a true statement. Let's bring our coordinate plane back. X, Y. These ones that were solutions, let me go ahead and plot these points. 0, 2 would be an X of 0 and a Y of 2. -4, -2 would be an X of -4, so left 4, down 2. Two, 4. It's an X of 2, 2 to the right, a Y of 4, 4 up. Will you look at that? Well, don't use a cloth as a ruler. That's what we just learned, everybody. A cloth is flimsy. It does not serve the purpose of a ruler. It's much easier to freehand it. But notice, look at these three solution points. They all fall on the same line. That's why an equation that only has x to the first power and nothing higher is called linear. Because if you take all the solutions, they form a line. Points on this line will be a solution. Like here, this is a point on the line. What is that point? -2 on the x, 0. Surely does check. Plug in -2. -2 plus 2 is what? 0. Now, by the way, I want to make a note. I had to be really careful to try to make these equal distant. Because when you're drawing them out, if the tick marks aren't the same size apart, your line's going to get all wonky. You don't want that. So let's go ahead, graph another equation. By the way, that's kind of what we did there. We just graphed an equation. We graphed an equation by plotting points. Let's do the same thing with x minus 2y equals 0. Well, what we can do is solve this equation for y. Now, why would we do that? Well, it'll allow us to pick our x's and then plug them in. Here, I'll show you. If we solve this for y, subtract x from both sides. Oops. Subtract x from both sides, divide both sides by -2. Y equals negative divided by negative is positive. Y equals x over 2. So to get a y coordinate, all we have to do is take an x and divide it by 2. Let's make an xy table. What that means is make a table of x's and y's. Since we're going to want to be able to divide the x by 2, our x's that we pick should be even numbers. And I'm going to pick a couple of negatives. I'm going to pick 0, and I'm going to pick a couple positives. Unless the table's already given to you, you do not have to pick specific x values. Because the whole purpose of an x is to find the y. -4 divided by 2 is -2. -2 divided by 2 is -1. 0 divided by 2 is 0. 2 divided by 2 is 1. 4 divided by 2 is 2. Now, another thing you could have done is just, we're going to come back to what to do with these points in a second. This is like a pause. This isn't more of the same. This is another thing you could have done. Just start by picking some x's and then plugging them in. So if you plug in -2 and then solve for a y, you'll get your y. It just so happens, since you notice -2, -1, we got that point anyway. It's just that if we were putting in, say, a -1 here and solving, you'd end up with fractions. Those would still be on the line, but for graphing purposes, it's a lot easier if you're graphing whole numbers and then not having to figure out, okay, what's half, what's a fourth. So by solving this equation for y first, when it was still in terms of x, it kind of gave us a clue of what kind of x would give us whole number y's. But really, to draw a line, you only need 2 points. 2 points are enough to make up a line. But let's plot all 5 of these. Give a graph, label y, label x. Looks like we need 4 at least in all directions. Try to keep them equal. If you have graph paper, that makes things a lot easier. So -4, -2, that's an x of -4. A y of -2, that's right here. -2, -1, an x of -2, a y of -1, that's right there. 0, 0 is right there. An x of 2, a y of 1, that's right there. An x of 4 and a y of 2, that's right there. So you can kind of see there's our line. And we put arrows on both sides of the line to indicate that it goes off in both directions forever. So that's graphing an equation by plotting points. Let's do another. Let's do x plus 3y equals 3. Well, I could just start picking a bunch of x's, but seeing that y is multiplied by 3 here, that tells me that there's going to be some weird dividing by 3 stuff going on. So I'm going to go ahead and solve for y. I'm going to solve for y by subtracting x from both sides. So 3y equals 3 minus x. I'm going to divide both sides by 3. And y is going to be 3 minus x over 3. So let's make our x and y table. We know how to get our y's. We're going to pick our x. We're going to plug it in. We're going to get our y. Okay. So I'm going to go ahead and pick a couple negative x's. Ooh. I want to be careful with how we pick again. If I just randomly pick some x's, I'm going to run into the same situation, but it has to be something that I can go 3 off of and then divide by 3. So since we're going to be skipping 3 off of it anyway, if x was divisible by 3 and we did 3 minus that x and divided by 3, we should get some nice even y's. So I'll pick some multiples of 3. -6, -3, 0, 3, and 6. These should work. And this is just me thinking it through. You can just pick a bunch of things if you want until you have 2 that did work, that were graphable. If I plug in -6, 3 minus -6 over 3 would be 3 plus 6 over 3, which would be 9 over 3, which is 3. If I plug -3 in, 3 minus -3 is 3 plus 3 over 3, which is 6 over 3, which is 2. If I put 0 in, 3 minus 0 is 3, 3 over 3 is 1. So 3 minus x over 3. If I put 3 in, 3 minus 3 is 0. 0 over 3 is 0. If I put 4 in, or sorry, if I put 6 in, 3 minus 6 is -3. -3 over 3 is -1. So for x plus 3y equals 3. Looks like 6. -6, 3. -6 for the x. +3 goes up. -3, 2. And again, I'm pulling these right out of the table. X and Y just becomes an ordered pair. X and Y just becomes an ordered pair. -3, 2. -3 on the X, 2 on the Y. 0, 1, just pulling it right out. 0 for the X, 1 for the Y. 0, 1 was right there. 3, 0. That's there. 6, -1. 1, 2, 3, 4, 5, 6. Down 1. My lack of foresight, not having a ruler here, means that's the best we're going to do with that line. I am not an artist. Another thing you can do to graph is just identify the intercepts. That's a nice, easy 2 points. So what do I mean there? So 2 points is enough to draw a line. So assuming they don't end up being the same point, let's look for where x is 0 and where y is 0. That'd be finding the intercepts. When x is 0, that's a y-intercept. That'll be our point on the y. When y is 0, that's our x-intercept. It'll be our point on the x. If we plug in 0 for x and solve for y, we get y equals 1. Plug in 0 for x, plus 0 is itself. 3y equals 3. Divide both sides by 3. That's what happened there. Y equals 1. Let's plug 0 in for y. So again, x plus 3y equals 3. If we plug 0 in for y, 3 times 0 is 0. X plus 0 equals 3. X plus 0 is just x. So x equals 3. Now be careful. This is 2 separate points. It's not a point where x is 3 and where y is 1. That is something completely different, unrelated. This is 2 separate points. One where we plugged 0 in for x and got an answer of y. So that's our 0, 1 point. A second point where we plugged 0 in for y and got an x. That's our 3, 0 point. 3, 1, not a point that would satisfy this equation. But once we found our intercepts, the only time this won't work is when it's 0, 0, because that means it'll be the same for both, and we would need to pick another number to get a second point. But once you find your intercepts, all you have to do is plot them. 0, 1, so no movement on the x, but 1 up for the y. 3, 0, No movement for the y, but 1, 2, 3 to the left. There's our 2 points. And we draw our line through them. It's the same one as the one we did those 5 points. But we didn't have to do any weird solving this way. All we do is plug 0 in for x to get one of the points, plug 0 in for y to get the other one of the points. So, new equation. New equation. 3x plus 5y equals 10. And actually, I don't want to do 3x right now. I want to do 2x. 2x plus 5y equals 10. Let's plot using intercepts. So we want to find the 2 points. My old high school Algebra 2 instructor used to call this the googly eyes method. 0 for x, 0 for y, like a pair of googly eyes. If we plug 0 in for x, two times 0 is 0. 0 plus 5y is just 5y. Divide both sides by 5. We get y equals 2. The googly eyes method, it's also called the cover-up method. Why? Because when we plug 0 in for x here, that x goes away. And we can see 5y equals 10, y has to be 2. Let's go ahead and find the other point. We're going to do that by taking the same equation and plugging 0 in for y. So 5 times 0 instead of 5 times y. 5 times 0 is 0. 2x plus 0 is just 2x. Divide both sides by 2. When y is 0, x is 5. Again, cover-up method. When y is 0, so 2x equals 10, x is 5. Once we have those 2 points, the x-intercepts at 5, the y-intercept is at 2. X-intercepts at 5, 5, 0. Y-intercepts at 2, 0, 2. Those are our 2 points that we can then use to draw the line. Even if it doesn't work out to whole numbers, you can still use the intercepts. If it asks you to use the intercepts to find it, then you have to. If it gives you a table to fill in, then you have to. But if it just says graph by plotting points, or it just says graph and doesn't specify the method and how to graph, then you can use any method available. Let's look at 2x plus 3y equals 4. Let's find the intercepts. XY method with the googly eyes, 0 for x, 0 for y, 2 separate lines. If we plug 0 in for x, this goes away. We're left with 3y equals 4. Divide both sides by 3, we get y is 4/3. For the sake of graphing that, we're going to change it to a mixed number. So 4 divided by 3. 3 goes into 4 once. And we want the fraction remainder. 1 1/3 is our y. 1 1/3. 4/3 is a fine answer too. It's just I know I want to graph it. And if you tell me to graph 4/3 and you tell me to graph 1 1/3, I know which one I'm going to be able to find quicker. Let's go ahead and plug 0 in for y. Plugging in 0 in for y, plus 3 times 0 plus 0. That goes away. 2x equals 4 is what we're left with. Divide both sides by 2. We get x equals 2. If I were to graph these points, I'm going to do the one without the fraction first. X is 2 and y is 0. That's an x-intercept. When x is 0, y is 1 1/3. So if I imagine that between between 1 and 2, this got split up into thirds. 1, 2, so it's 1, 2, 3 pieces. 1 1/3 would be right here. And then use your straight edge. You just fold up a piece of paper. Use your straight edge to draw the line between those 2 points. So that's how you'll plot intercepts. The rectangular coordinate system, we draw a horizontal line and a vertical line that intersect at right angles. The horizontal line is the x-axis, and the vertical line is the y-axis. The point of intersection for these axes is their 0 points, known as the origin. Positive numbers are shown to the right and above the origin. Negative numbers are shown to the left of the origin and below the origin. Each point in the rectangular coordinate system corresponds to an ordered pair of real numbers, x, y. The first number in each pair, called the x-coordinate, denotes the distance and direction from the origin along the x-axis. The second number in each pair, called the y-coordinate, denotes the vertical distance and direction from the origin along the y-axis. So what does this mean? If we wanted to plot the point -2, 4, the -2 in the first position, that's the x-coordinate, and that tells us to go -2 on the x-axis. So 1, 2 to -2. And then the 4 in the y coordinate tells us to go +4, up 4. So from -2, we go 1, 2, 3, 4 up. And we plot our point. Let's plot the point 4, -2. The x coordinate is +4, so that tells us to go right 4 on the x-axis. And then the y coordinate -2 tells us to go down 2. So from +4 on the x down 2 to this point right here. Now, looking at the coordinate plane, something you might need to know at some point are the quadrants. So the first quadrant is what we call the upper right. And then the second quadrant is what we call the upper left. The third quadrant is what we call the lower left. And the fourth quadrant is what we call the lower right. So positive is in quadrant 1. Negative positive is in quadrant 2. Negative is in quadrant 3. And positive negative, like this point 4, -2, is in quadrant 4. A relationship between two quantities can be expressed as an equation in two variables, such as y equals 4 minus x squared. A solution of an equation in two variables, x and y, is an ordered pair of real numbers with the following property. When the x coordinate is substituted for x and the y coordinate is substituted for y in the equation, we obtain a true statement. So an ordered pair xy is going to be a solution to an equation if when we plug those values in for x and y, we get a true statement. A graph is just a collection of all the points that make it a true statement. So in order to graph, we just will select some x's, plug them into the equation, and get y values that work. And once we have a collection of these points, we'll be able to draw the shape through the points. So to graph y equals the absolute value of x plus 1, we will select integers for x, starting with -4 and ending with 2. Now, where did these numbers come from? We just made them up. There's not a specific starting x or a specific ending x or a specific range of x's. We just like to pick a couple negative, 0, and a couple positive. So you can see when we plug -4 in for x, we get -4 plus 1 or -3 inside the absolute value. The absolute value of -3 is +3. So -4, 3 is a point on the graph because -4, 3 is an ordered pair that makes a true statement when it gets plugged in to the equation. If we plug -3 in, -3 plus 1 is -2. The absolute value of -2 is +2. So -3, +2, that's a point on the graph. Plug in -2. -2 plus 1 is -1. The absolute value of -1 is +1. That gives us the ordered pair -2, +1. Plugging in -1, -1 + 1 is 0. The absolute value of 0 is 0. -1, 0 is a point on the graph. And right now you're thinking, oh my, is he really going to go through every one of these? I am. I'm really going to go through every one of these. It's important that we know the process of plugging the point in, plugging the X value in, and getting the Y value back. So we plug in 0 for X, 0 + 1 is 1. The absolute value of 1 is 1. 0, 1 is a point on the graph. Plug in X = 1. Replace X with 1. So instead of X + 1, it's 1 + 1. That's 2. The absolute value of 2 is 2. And then finally, from the X values we chose for our table, if we plug in 2, we get 2 + 1 is 3. The absolute value of 3 is 3. 2, 3 is a point on the graph. If we take all of these points we found and plot them on a coordinate plane, we can connect them and we get this shape. Now, you don't need a graphing calculator for this course, but if you have one, let's talk about it for a second. Graphing calculators and graphing software packages for computers are referred to as graphing utilities or graphers. To graph an equation in X and Y using a graphing utility, you enter the equation and specify the size of something called the viewing rectangle. The viewing rectangle is basically what you see on your screen. When it shows you the graph, what are the values for X that you want to see? What are the values for Y that you want to see? The size of the viewing rectangle sets minimum and maximum values for both the X-axis and Y-axis. The -10, 10, 1 by -10, 10, 1 viewing rectangle is called the standard viewing rectangle. So here, as opposed to a -10, 10, 1, is a -100, 150 by -100, 110 viewing rectangle. And you can see that these are the values: -100, 150, -100, 110 for these categories: X min, X max, X scale, Y min, Y max, Y scale. The min is the minimum value for the axis. The max is the maximum value for the axis. And the scale is by how many we want to skip. So what are we counting on the axis? If it's a scale of 50, we'd be looking at 50 and 100, or -50 and -100. For a scale of 10, we'd be looking at 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Through -10, -20, all the way to -100. Skip counting by 10. So what's the meaning of this type of viewing rectangle? The first number is the minimum X value. The second number is the minimum or the maximum X value. And then the third number, in this case, the 50, is the distance between consecutive tick marks on the X-axis. And the other three numbers refer to the Y. The minimum Y value is -100. The maximum Y value is 100. The scale, the distance between consecutive tick marks on the Y-axis, is 10. So if you are using a graphing calculator to graph, just be aware that you can change the viewing rectangle. And as you change the viewing rectangle, that's going to kind of, stretch and shrink and uh, move in on different portions of the graph. Uh, Depending on what the viewing rectangle is. But some things that won't change no matter what type of view you have of a graph is a graph of, or I should say, are the intercepts of a graph. So now we're back to talking about stuff that applies to everybody, not just people with graphing calculators. And again, you don't need one for this course. An x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. The y-coordinate corresponding to an x-intercept is always 0. So for an x-intercept, y will be 0. On the other hand, a y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis. And the x-coordinate corresponding to a y-intercept is always 0. So for a y-intercept, the x is 0. Let's find the x and y intercepts of this graph. Where do we cross the x-axis? We cross the x-axis at x equals -3. Y is 0. The point -3 is 0 is the x-intercept. Or we can just say the x-intercept is -3. The y-intercept, where does this graph cross the y-axis? Well, that's up here at 5. X is 0, so that's the point 0, 5. Or we can just say the y-intercept is 5. Divorce rates are considerably higher for those who marry younger, but education may also play a role in the longevity of a marriage. The equation D equals 1.8n plus 14 models the percentage D of marriages that end in divorce after n years when married with a high school diploma but no college education. Determine the percentage of marriages ending in divorce after 15 years for high school graduates with no college. So let's break down what we have here. We have an equation. D is the number of marriages that end in divorce after n years. Here we're asked to find the number of divorces after 15 years. So we're going to plug 15 in for n. 1.8 times 15 gives us 27. 27 plus 14 gives us 41. So the percentage of marriages ending in divorce after 15 years for high school graduates with no college is 41%. And that's it for this topic. The objectives in this topic are find the domain and range of a relation, determine whether a relation is a function, determine whether an equation represents a function, evaluate a function, graph functions by plotting points, use the vertical line test to identify functions, obtain information about a function from its graph, identify the domain and range of a function from its graph, and identify intercepts from a function's graph. Previously, we were talking at one point about ordered pairs, an x value
and a y value. In everyday life, we encounter many things that are dependent on something else. So if you're mailing something, the cost of mailing a package would depend on the package's weight, or a test grade that you earn is dependent on your number of hours of study. In math, we express a relationship between two things as a set of ordered pairs. So if we literally have a set of ordered pairs, let's not use XY. Let's actually fill one out here. Combine this up with the first example. Okay, just something simple like this. So this is a set containing 1, 2, 3 ordered pairs. The ordered pair 1, 2, ordered pair 3, 4, the ordered pair 5, 6. The inputs are the X value, the first value. And together, all of the inputs make up the domain. The outputs are our Y value, the second entry in each ordered pair. And together, the set of all the Y values makes up the range. And this is the domain and the range of the relation. So the relation here is relating 1 to 2, 3 to 4, and 5 to 6. It's a relation of inputs and outputs. The input 1 gives the output 2. The input 3 gives the output 4. The input 5 gives the output 6. So here you might ask, would 7 give an output of 8? And here the answer would be no. The input of 7 does not exist. There are only 3 inputs here. The only inputs are the domain, the set 1, 3, and 5. They're the only inputs that this relation has. The outputs, the only possible outputs, are 2, 4, and 6. An input of 1 gives the output of 2. An input of 3 gives the output of 4. An input of 5 gives the output of 6. So the domain is all of our inputs, all of our possible inputs. The range is all of our possible outputs. So I mentioned earlier that a test score could be very dependent on hours of study. Look at this table. We're going to call that X. Test score, we're going to call that Y. Okay, I have made here for you this fancy looking table. Isn't it great? It shows for 5 imaginary students the number of hours they studied and their test score. We're calling hours of study X. We're calling the test score Y. What can we get from here? Well, let's write the set of ordered pairs. Well, from each of these, we know we can pool the ordered pair X, Y. So 892, 358, 1198, 572, 886. So I pulled those straight out. If I wanted to express that as a set of ordered pairs, I would literally write a set containing these ordered pairs: 892, 358. Notice there's a lot of commas here because I have a comma inside the parentheses, inside the ordered pair. And I have a comma between the ordered pairs, between the elements of the set. 1198, 572, and 886. So that would be my set of ordered pairs. I can get the domain. The domain is all the set of all the possible inputs. I'm going to go ahead and put them in an order. Sets don't have repeats. So 3, 5, 8, and that's there twice, but I only have to write it once. Sets don't have repeats. And 11. Or it doesn't have to be in order. You can just go 8, 3, 11, 5, and then go, oh, I already have an 8. Don't write the 8 down again and be done. Order doesn't matter. Just no repeats, but it can be in any order. So the range, I'll just do that going in order thing. That looked fun and easy. I didn't have to keep track that way. So 92, 58, 98, 72, 86. So there's the domain and there's the range. Set of all inputs, set of all outputs. Now, like I said, a set of ordered pairs is always called a relation. We have a special type of relation called a function. This would not be a function. And here's why. The most basic rule for a function is that it cannot have any repeated x values. So here is an 8 and here is an 8. And it's a repeated x value. It's there twice, but it has 2 different y values. And of course it has 2 different y values, because if they had 2 of the same y values, then it would be the same item and we would be wrong in having it written out twice. But it's not 892 and 892 with just an extra 892 in there. This is an 892 and this is an 886. That's okay. There's nothing wrong with that. It's just a normal run-of-the-mill relation. It's not a special relation that we call a function. Marker down. Marker down. Okay. So let's look at a few different relations and decide whether or not they are functions. Here we have the set containing the ordered pairs 3, 1, 2, 5, -4, 2, -1, 0, 3, -4. Is this a function? Is it? Ask yourself, do I have any repeated x values? Yes, I do. So no, it is not a function. -1, 4, 2, 3, 3, 4, -4, 5. Is this a function? Yes. You might be saying, but wait a minute. You've got 2 4s there. These 4s are y values. We're allowed to have repeated y values in a function, just x values. And our x values here are 4 different things: -1, 2, 3, and -4. So why is a function special? What makes it different from a relation? Well, it's still a relation, but it's a special type of relation that's called a function. And the thing that makes it special is that since there are no repeated inputs, an input of -1 will always go to 4. It won't go to 4 sometimes and then go to -3 other times. An input of -1 will always lead to an output of -4. An input of 2 will always lead to an output of 3. An input of 3 will always lead to an output of 4. An input of -4 will always lead to an output of 5. There's never any confusion about which one is which. And that is what makes a function special.